Hi guys, I thought today I'd get us together to show you how I would go through one of these types of friction on a plane questions. And the one I'm going to look at is from mixed exercise 5. And it's question 7. Now, I'll read the question to you. It says, a particle of mass 2 kilograms is moving down a rough plane that is inclined at alpha to the horizontal. Right, I don't think I need to write any more, just read any more just at this point in time. I'm going to make sure I've got plenty of space. So that's where I've got to so far. A particle of mass 2 kilograms is moving down a rough plane that is inclined at alpha to the horizontal. It says where tan alpha is 3/4. Now that's important. It says tan alpha is 3/4. Now if you think about what that could have meant, if this was alpha here, now I know tan is opposite over adjacent, so opposite over adjacent. If I've got these two sides, I would know then Pythagorean triple 3, 4, 5 triangle. So that tells me that cos alpha is adjacent divided by hypotenuse 4/5, and sine alpha is 3/5. So that's good information. Then it says a force P acts horizontally upon the particle towards the plane. And here you can see I've got the classic alternate Z angle. So that must be alpha up there too. And it says given the coefficient of friction is 0.3. It's telling me mu is 0.3, and the particle is moving at constant velocity. So if it's constant velocity, there's no resultant force. It says calculate P. Right. The other thing, coming back to the beginning, is it says a particle of mass 2 kilograms is moving down a rough plane. So it's coming this way, so friction must act that way. Now I want to just resolve these two forces perpendicular and parallel to the plane. So I can put in my right angle triangle there. And I can see that this, knowing that is alpha, this is 2g cos alpha, and this is 2g sine alpha. And looking at the force P, if I put a right angle triangle there, I can see that this is P cos alpha, and this is P sine alpha. Now important things also about that is this is pushing into the plane, so it's wanting to push an element up there. So I've got a force going up there and it's pushing in down there like that. And in terms of where the mass is acting, that's going in that direction. And the reason why I've put those together is because when you think about the reaction force, you've got this coming down and this coming down. So the reaction force has to counteract two forces being pushed down and stop them going through the plane. So the reaction here is P sine alpha plus 2g cos alpha. And I think I've nearly got all my information on there that I need. So let's start to think about solving it. So let's equate forces. So if I look going up the plane, I've got P cos alpha plus the friction, and that's going to be equal to the forces coming down the plane, equals 2g sine alpha. Now, as an aside, again, I've got F equals mu r. We know it's moving, it's gone past the limit, so we are now at maximum friction. So that would be 0.3 times P sine alpha plus 2g cos alpha. So putting everything together over here, I've got P cos alpha plus 0.3 P sine alpha plus 2g cos alpha equals 2g sine alpha. Okay. Now, at this point, I'm going to bring these bits in. So I've got P cos alpha, that's 4/5, and I'm going to change these to a decimal. I think it might make it just a little bit easier. 0.8 and 0.6. So I've got 0.8 P plus 0.3 times 0.6 P plus 0.3 times 2 times 9.8 times 0.8 equals 2 times 9.8 times 0.6. And when I work them out, I've got 0.8 P plus 0.18 P plus 4.704, when I work that out, is equal to 11.76. So if I combine these together and take that away from both sides, I should have 0.98 P is equal to 7.056. Dividing both sides by 0.98, I get P is equal to 7.2 newtons. Okay, and that's the correct answer. So, things to note. A big diagram, give yourself space to label and think about the directions that the forces are acting in. So this mass here, this weight here is pulling that way and that way. And when I'm pushing into there, that's pushing into the plane and up the plane. And that direction of those two forces there is really, really important. Because where people go wrong with this is they mess up thinking about the reaction force. You've got that coming down and that coming down, giving a combination of those two in the reaction. So one of the key things was resultant force equals 0. So I could equate the forces up the plane equaling the forces down the plane. And I used the F max equals mu r and bringing that in. And remember I did that as just like a little aside, so I got that sorted out. What I don't like to see is F equals mu r stuck in the middle of there and it being confusing. So really what I want to see is the sections and some little asides brought in. I felt that this was really, really useful, and always look out for if they give you the tan of an angle is something, or the sine of an angle is something, or the cos of an angle is something, always set that out as a right angle triangle with the fraction that you're given, and you should be able to use Pythagoras to find the other side. And they're nearly always Pythagorean triple, so that's something that you should look out for all the time. Okay, hopefully you found that useful, and there's something there that you can add into all your work, some technique that you can use all of the time. Okay, thank you. Goodbye.